Hi everyone, welcome back. We're going to continue with 3.3, real zeros of polynomial functions. Today's essential question is, how do I factor polynomials of a higher degree? So in the previous lesson you learned about synthetic division, long division, and we didn't really know what we were using them for, but in this lesson we're going to be using synthetic division in order to realize that you're actually finding certain values of a function, and you're also checking for different factors of a higher degree polynomial. The first thing that we want to focus on is the remainder theorem, and it's actually in your textbook. So go ahead and copy down this box right here, the remainder theorem. It says that if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. Now all of that might not make too much sense at the moment, but once we start using an example, it'll make a lot more sense. Essentially, though, what it's saying is that if I'm dividing using a certain number for my synthetic division, that is my x value, and then whatever remainder I get is actually the y value. So even though you get, some ugly remainder, that's actually the y value for your big higher degree polynomial. Okay, so let's go ahead and start by checking out this example. So let's go ahead and write it in. Example 1. We're going to be checking if, we're going to be evaluating the function at x equals 3. So in other words, we're going to be using x equals 3 and as our number for synthetic division. And the function that we want to evaluate it at is f of x equals x to the 4th plus 3x cubed minus 17x squared plus 2x minus 7. Okay, so just as we learned previously, we're going to set up synthetic division. With x equals 3, that's exactly the value you're going to use, and that's what we're going to be using for our division. So here, there's going to be a 1, a 3, negative 17, 2, and negative 7. Okay. So continuing with synthetic division, bring this down, we get a 1, multiply, I get 3, 6, multiply, 18, that would be 1, multiply, 3, 5, 3 times 5 is 15, 15 minus 7 is 8. So in this case, after dividing by x minus 3, I ended up with this polynomial of x cubed plus 6x squared plus x plus 5 plus 8 over x minus 3. What actually we just also found was that with this remainder 8 is that the value of the function at 3 is 8. And if I were to actually plug 3 into this entire polynomial, I would definitely come out with 8 as my value. So you can prove that to yourself if you want to check it out. I'm going to go ahead and jump to example 2 now. So the whole purpose of that is not only to realize that we can evaluate functions using synthetic division, but it's also to point out that if our remainder were to come out 0, then whatever root factor we chose here is actually a root for this polynomial. Okay? So the next one that I want to work on is f of x equals x to the 4th minus 9x cubed plus 28x squared minus 31x plus 16. What I want to check is if certain factors are actually factors of these two guys. So in the textbook, they're actually going to give you 2 or maybe 1 binomial. And what you're going to do is use synthetic division to check, okay, is it actually a factor of this entire polynomial? In this case, the 2 factors that I want to prove are x minus 1 and x minus 4. So show that x minus 1 and x minus 4 are factors of this function. Okay, So you can actually start with either one, it doesn't matter. I'm going to go ahead and start with x minus 4. So remember, when you're using synthetic division, you want to check when it's equal to 0. So in this case, I'm going to use x equals 4. So here's my 4. Let's set up our synthetic division. I have 1, negative 9, 28, negative 31, and 16. So here, bring down the 1, multiply, I get a 4, negative 5, multiply, I get a negative 20, 8, 32, that'll be 1, and then let's actually negative, sorry, I just realized this actually is 36, let's make that a lot easier for us. So minus 36x right there, and let's fix that over here. So negative 36 plus 32, that will give us negative 4. There we go. That's going to work much better. 4 times negative 4, negative 16, and that will give us 0. Okay, so because we ended up with 0 as our remainder, we know that x minus 4 is a factor for this entire polynomial. In other words, at this point in time, what I have done is I factored out x minus 4, and I'm left with x cubed minus 5x squared plus 8x minus 4. So at this point, I wouldn't need to use x minus 1 with the entire polynomial again, and actually I wouldn't want to do that. I would use x minus 1 and focus on this polynomial, the one that had x minus 4 factored out. The reason is because I want to use synthetic division again. So use synthetic division again. And this is to check if x minus 1 is a factor of this smaller polynomial. That way we can break this polynomial into something that's more approachable, most likely a quadratic. Alright, so we're going to go ahead and use that one. I'm going to go ahead and turn the page. So at this point, I need to prove to myself that x minus 1 is a factor for the entire polynomial, which means that I'm going to have to use x equals 1. So setting up my synthetic division, 1 will be right here. Over here, I'm going to use x cubed. Let's go ahead and write this to remind ourselves. X cubed minus 5x squared plus 8x minus 4. So the numbers, sorry, 1, negative 5, 8, and negative 4. Bring this down. I get a 1, 1, negative 4. That's going to be negative 4, 4, and then 4 right there. And look at that, I get another 0. So at this point, what we have is x minus 4, x minus 1, because that is now a confirmed factor. And then we have x squared minus 4x plus 4. And with this, we're going to go ahead and factor x squared minus 4x plus 4 because it's a quadratic that is a lot more approachable. So this I see as a perfect square trinomial. I'm going to go ahead and factor it all the way. X minus 4, x minus 1. This is going to be x minus 2, x minus 2. Or if you would like to abbreviate it, x minus 4, x minus 1, x minus 2 squared. Okay, so this is going to be pretty important because this suggests a certain multiplicity, as you guys might remember from the previous section. And this right here is actually the fully factored form for my original polynomial of x to the 4th minus 9x cubed plus 28x squared minus 36x plus 16. So this is our approach. It's going to be easier if we're given certain values to test at, but in some cases you might actually have to figure out certain values of your own and use synthetic division to confirm whether or not it is a 0. Okay, so quite a bit to go through. If you need to, go ahead and replay, rewatch, and move on to the Google form once you're ready. Have a good day, you guys.